Audio check. Okay.
I have to be careful when I take the I put the batteries in this thing, so.
Okay. All right, how's that sound? Okay. Great. All right. Thanks, everyone, for coming out. Well, we're going to get started now that we're catching everything on audio. So we wanted to talk about OpenAppID, which is actually the greatest thing that's been added to the Snort project, right? So this is, again, all open source stuff. Everything I'm showing you here today you can go and download for yourself. By the end of the day, you can have all this stuff up and running, right? And the point here is to completely open source application detection, right? So we have the capability sort of built into Snort, which is historically looked, right, IPS. Everyone knows that. I mean, this audience, yeah, okay, that's not new, right? But what we sort of added here is really to identify applications. Not just the threats and not just, what traffic's sort of out there, but a comprehensive framework in order to say, okay, well, what protocols are out there, what services are being run out there, what applications are being run out there, so all that can be identified. And that comes with an extensive new language to create application detectors, and I'll show you that, and show you how easy it can be to create your own application detector, right? Because we want to push this out there, and we're hoping to see as much success with this as with the Snort engine for IPS and for application detection. That throw it out there, throw it in the wind. It's now free. Anyone can download it if you want an application running on your network. If you want application detection running on your product, go ahead and add it, right? So we'll get it out there. So what we want to do is go over some basics of installations. I don't want to spend a lot of time on that because there's an awful lot of documentation online for getting Snort up and running. I'm just going to point out what's new, what's different to keep an eye open for. How we're going to about configuring OpenAppID, and then actually some of the information that's going to give us, because we're actually going to see like a lot of application statistics. We're going to see a lot of data being collected as far as what's being identified on the network. And then also, of course, how do we do application control? Because we're now going to have the ability to, say, block certain applications. Now that we can identify them, of course, we can start to lock them down. All right, so I sort of provocatively titled the talk that we can do an open source next generation firewall. Would take a second to define. I think it's worth doing, because if you were to ask 5 different security vendors to define next generation firewall, you'd get 6 or 7 definitions, right? Mostly self-serving. So, I mean, at least to take Gartner's, to say that we're going to have a firewall that's going beyond basic port inspection to do application level inspection, intrusion prevention, and sort of bring that intelligence into a firewall. And doing an open source firewall is pretty easy, right? I mean, of course, not going to work for an enterprise level, but if you want to spin up a little box and get a firewall running, that's really pretty simple. IPS, of course, Snort's been available for a long time. All it was lacking was the application control, and with OpenAppID in the latest version of Snort, you can now add that. So you can download that and have a completely open source next gen firewall. Right. Regular firewall, and that's simple. How complex do you need? I mean, like the one run that I've got running at home, just to have UGFW, which is, I mean, it's little Linux GUI. You can grab if you ever run Linux distribution, pop it up. I mean, the GUI, flip the on switch, put in a couple rules to let in 22 and 443, and that's enough for my network at home. If you're looking for something more than that, Google Shorewall wall. If you have a chance to set it up, that's a whole framework for sort of managing IP tables, right? But actually far more scalable. The IPS itself, nothing new there. Most people have seen Snort in some capacity, of course. You can download any time. And I'll take it for granted that that's kind of out there. If you've never used Snort as an IDS before, that documentation is out there. Just hit up snort.org. There's a lot of documentation out there. It's not that I want to skirt past it, but if it's in a white paper, you can grab offline. Let's focus on the new stuff, right? So application control. OpenAppID is there to detect and control applications, as I said. And I think it's a big deal that this is completely open source, because this was something we've been working on for a while and something that hadn't been put back into the open source community. This is something that happened after SourceFire was acquired by Cisco. Which I think is important because there was, as soon as SourceWare was acquired, there's a lot of end of the world proclamation that Snort wasn't going to be open source anymore and Cisco's going to ruin and all that stuff. I think it's telling to say that they kind of doubled down on open source and said, no, we're just going to move more stuff out of there, right? So this complete framework for detecting applications is open source. So are thousands of application detectors that you can also download and load into this language. So you're going to be out of the gate to be able to detect an awful lot of applications. So this actually runs as a preprocessor to Snort. Right? If you've ever seen Snort before, there's a number of preprocessors sort of help manage traffic before the IPS starts examining it with to match Snort rules to find attacks. Because if you're looking at network traffic, you need to be able to rebuild it to look at it, right? If IP fragments are going across, you need to be able to rebuild that. You want to be able to rebuild a TCP session. You need to normalize HTTP traffic if you're ever going to figure out what's in there. Those are all components of the Snort engine known as preprocessors, the way that we can assemble streams of traffic as packets come through and then pass that on to the rules engine. So this is another preprocessor that we can add to it. With the requirements that you also have to be running the preprocessors for reassembling IP fragments, for TCP streams, and then whatever application normalization you want to do. So if you want to identify web applications, you have to be running the HTTP preprocessor to do all that kind of normalization. That's not a real big prerequisite because those are all built in like the default Snort configurations, right? So that's not even an extra step. What is new is that you have to have Lua libraries installed. The application detector scripts, or at least most of them, are written in Lua. So we need to have those libraries installed. When you compile Snort now, it's one of the bigger changes as far as getting this up and running. You need Lua installed, and then when you compile Snort, we add the enable OpenAppID flag, right? Then you also need the application detector package. And you'll see that if you go to snort.org, go to the downloads page, now have space for the Snort program itself, for data acquisition part, for the rules, and now you'll see an application detector package that you can download as well. And so the latest version of Snort is actually an alpha release. Once that's fully, or probably actually when it's beta, we'll start seeing regular releases of updates to the application detectors. Right. Got that. And then we're going to do a little bit to modify the snort.conf. Whereas there's a single little text file, you're going to tell Snort how to run. All we really need to do is get in there and add a few lines right here, right? If you haven't seen that before, there's some guides online we've put up on the Snort blog as far as editing this, but really there's just a couple lines we paste into the very end of the preprocessor section of the snort.conf. And all we're going to really tell it is sort of, okay, we want to run AppID. You can specify the name of the log file, because it's going to have an awful lot of application statistics. And you can specify it's just the file name where that's going to go. The app stats period is just, okay, how many minutes until I report these logs? And then you have to name the directory where you've put the application detectors, right? Those scripts I was just talking about downloading, we just have to point it to wherever you've unzipped that file. Okay. So that'll take you about a minute once it's compiled. If you've ever compiled in Linux before, this really isn't going to take you very long at all. And one other thing we have to modify is the output we're getting from Snort. One of the last things you configure when you're setting up Snort is, where is the data going to go? You set up an output module. If you look through, there's a lot of output modules listed. Like you can report directly to syslog or to a MySQL database, which shouldn't do those things. There's a lot changing, and network speeds are getting faster. So we really want everyone reporting to what we call the unified format. So it's just a straight binary log format. The idea being you want another process to then read the unified format and put it into a database or syslog, wherever you want it to go. But this is going to keep the process a lot faster. It also allows us to continue to add data types, which is not something we can easily add on to every other output possibility. So as we've added things like the additional data you're getting with a Snort alert now includes stuff on the application, you're not going to get that unless you're using the unified output, right? So you'll get a binary output, and then we just need another program to translate that. It's typically Barnyard, if you've ever set up Snort before. But I'll show you there's scripts that are actually packaged with Snort when you download it. There's a tools subdirectory, and there's scripts in there to actually parse out this data as well. And I'll show you how those work. All right, so what all is in that application detector package? You have those detection scripts we talked about, those Lua scripts. There are some port detectors. So if you just want to do a detector that says, okay, any UDP traffic on this port is this application, you can do that. There's a couple of those packaged in with it. But for the most part, the Lua scripts allow you to do far more complicated detection. There's also a file called app mapping.data, which has some metadata about all the different detectors. We'll take a look at that because it's how you can see, like, what different detectors are in there, what name they're using, which we'll need to match up to rules when we start controlling applications. And there's some Lua libraries that just come with it as well. But as long as we just unzip that file and then your snort.conf point it to that directory, you'll be set. Come back to that. All right, so once it's up and running, now we can actually watch the traffic going through the Snort process to identify applications. And in fact, you can get 4 different applications identified in each session. So you can actually have it come back and say, well, there's, so if you go out and you're doing something on Facebook, it might come back and say, well, the service application is this web server. The client application is Firefox. The payload application is Facebook. And the miscellaneous application come back as Facebook chat, right? If we have that kind of view of the data. So we'll actually see a number of applications get identified each time you go out and on any network session, right? Output we went over. All right. So once we've done those things, I've made the changes to this snort.conf. I literally, all I did was the stuff in the slides, right? I took that output, pasted it in the snort.conf. I want us to go promiscuous. And now I've restarted the Snort engine, and we see it's come up successfully. So it's commencing packet processing right there. Now if I launch a web browser, say we go, I go to Google. I search for CNN, and then I go over to CNN. All this should be logged by the Snort process. So I close that down, stop Snort here. I'll go over to my log directory, and I'll see we've created a couple files. There's your Snort, usual snort.log. You see there's 0 bytes in there. Well, I didn't have an IPS rule fire off in the time I was running that, which good on this network. I mean, you usually wouldn't think a few seconds would be enough, but don't usually want to turn on my wireless card when I'm at these conferences, but the demo would have been pretty boring otherwise. But in addition to the usual Snort log, you'll see that we're getting this file as well, the app stats log. So now that's the data I'm getting from the new OpenAppID preprocessor. And again, if you look into when you unpack Snort, right, it's got all the source files, it's got the documentation, all that stuff. There's also a tools subdirectory. There's a couple of programs in there for reading this file format, because this app stats file is binary. But if I run the U2 OpenAppID program on this file, here we see it outputting the application data we've seen. So it fired on DNS on Jabber, picked up, I was using Chrome, saw DNS fire again, and we saw HTTP happen. And then went HTTPS. We see it go to CNN.com, and then we also see double-click, Trusty, Washington Times, moat, and point rule. I don't actually know what some of those are, but there are enough different adware types of things built into CNN that it actually flags on those types of applications. So we're going to get all that back. You'll see in addition to the app name here, I've got the stat time, you know, when did this occur? So I'm going to see sort of the first, initial browser opening up, and then we have our session here at the same time. And then we're also seeing, you know, transmitted and received bytes, right? So we're pulling traffic immediately, not only on what applications are out there, but how much traffic's being sent to them, right? And it comes, so now that I've run this program, I've got it in this text format, and you can parse it wherever you want. I mean, it's trivial to go from this data to get it into Splunk and start looking at graphs of what applications are using the most bandwidth on your network, right? Once we've got that data. And of course, we identified CNN.com because it's, you know, there's a known web detector for it. Let me start Snort up again. All right, so that's running. So let me fire up the web browser and instead pull up the circlecitycon website. All right, in that case, all we saw, you know, Chrome as a client, we saw DNS fire, and we looked up, you know, what we're trying to get to, and we saw HTTP, and we saw Jabber. So that must be something Chrome's doing to, right, probe out a Jabber. So it doesn't come back and say circlecitycon, right? It's not an app detector that's built in there. But we can fix that. What else do we want to look at? Let me show you this. This is what happens when a IPS alert fires. This is the data you'll usually get back from Snort. And what I've done here is actually wrote a rule to detect an application. Right? So this was just firing on, okay, just detect to see if anyone's using Reddit. So we get the actual packet flagged, and we can see it going out there. But you also see this new field. Why am I clicking it? Of course, it's going to go ahead. This new field here called AppID. So this is actually something you're going to get back with every one of your IPS alerts. It's going to tell you what application was being used when this alert fired. All right, so it's additional data you have. And that's also additional data we can make available to the Snort rules language. So that when you're writing rules, you can actually say, okay, we'll only fire for these applications, which gives you a few things you can do. Oh, and then to point out, if you're not using the unified file format, you're also missing out on some things we can pull out of the data. Like in this case, for all web data, I can flag the HTTP URI and hostname, which is something if you're using like the standard dump to syslog, you're not getting because it's an additional file type we've added recently, and it's really just in that binary unified file format, right? So there's a couple things in there that are missing out if you're using one of, say, like one of the old GUIs, acid or base, and those things that are still floating around for no good reason. But they're out there. All right, so we're actually adding the OpenAppID or AppID keyword to the Snort rules language. So when you're writing a Snort rule, you can now specify what applications to fire on, which immediately going to give you some control, as well as better tuning, right? So if you wanted to, if you knew you were looking for a vulnerability even, and you knew it only affected a certain application, typically you have to write a rule saying, okay, well first I got to check these bytes and these bytes to even make sure it's the right application, right? If I'm looking for DNS, I got to check to see what port it's on as a part of my rule. I got to check to see what bytes are here to see if it's a DNS query or not. Whereas now you can, might just be able to add, okay, AppID DNS, and it's taken that part of it out of it, right? We have another portion of the engine identifying applications. So if you were spending a lot of time writing Snort rules to identify application, service, or things like that, we've taken that out. or more directly, now we can just create rules to fire off when certain applications go off. And then if we set those rules to block, we're doing application control, right? So let's say we have to make the office a little more productive. We want a rule just to block Reddit, right? So that if we want to stop people from using the site, we now be able to we have our identification in there. So let's write a rule that will actually drop all that traffic. Well, the first thing I need to do is I need to know what OpenAppID's name for Reddit is. I mean, you could probably guess. There's not a lot of ways to write it. But maybe I don't know if there's a capital R or not. So I want to double check. So the first thing we do is look at this app mapping.data file that's included. And it just matches up. There's like a long name for the application, a short name for the application, and a number for each application. We want to use the long name to find the short name, right? So we'll search through the file, we don't find that, but that short name is what we're going to embed in a snort rule. Now let me find that. We go back here. I'll go to my AppID directory. So let's search through the app mapping data for Reddit, and we'll find, okay, the long name, here, that's identification number, 804. And then here's the short name for Reddit. So that's the one we want to put in our rule. Or if you just want to see like what applications we've got, like, okay, what can we do with Dropbox and OpenAppID? I mean, let's search through the file, and we'll come back and show you what applications are in there. So there's Dropbox just all together, but there's also Dropbox upload, Dropbox download, and Dropbox share, right? So even within one web application, there's sort of sub-applications if you want to get real granular on what control is going on, right? So you might want to poke around the file and see what application detectors are actually in there. So for our purpose, I have my short name here. I need Reddit. So I can write a snort rule now to say, okay, well, let's get back to work. Now, there's a lot of stuff going on here. If you've never seen a snort rule before, if you have, there's only one real change here. So I'm saying alert, if the protocol's TCP coming from any destination, any port, going anywhere on the network, any port, right? So if you want to get granular and limit IPs, maybe you're only doing this for your dev network, if they're the particularly lazy ones, right? So you can get down and limit what space is actually being blocked there. But really what I've said is if I want to block anyone on my network from using Reddit, well, any. I've got a message in there that's going to appear when the rule fires. Just says get back to work. And then we have the app ID keyword. And in this case, I've expanded. It says Facebook and it says Reddit. So you can actually list up to 10 applications in a rule. Of course, it's an or. It will match on any of them, any one of them. Yeah, is there a question? The easier way would be to use more than one rule, but I guess you could actually identify a custom app and embed application detectors for all the other apps in it, right? I mean, it'd be one way to do it, but from a manageability perspective, I'd just use another rule. Yeah, no problem. Oh, and the SID and revision, I mean, it's just an identification number. You give every snort rule an ID number. So like custom is started at 1 million, and then revision is just a revision number. So every time you change a rule, you're supposed to increment it, the idea of just, version control. So all that's really standard. The only thing different there is AppID : right, Facebook, Reddit. So with that rule running, I'm going to detect any of those applications going through my network. Now if I go back and change where it says alert, I change that to drop. Now we're going to be dropping this application whenever we see it. Right? All right. Now one of the other benefits of OpenAppID is that you can write your own detectors. Also that everyone else can write their own detectors, which is great because we're actually seeing a lot of interest from other software developers, from other manufacturers, and like, hey, we want our stuff identified. Like even from some like Internet of Things vendors. with devices not usually associated with security, saying, hey, this is an open standard now. Well, we want to make sure our stuff's going to get picked up. So we should actually see detection capabilities growing as the community, again, like, hey, if you read a detector, throw it on the mailing list and let's all roll it in, right? But say we want to track application stats for who's going to CirclecityCon. One option to do application detection is to detect by port. That's obviously won't look for detecting CirclecityCon. It's not going to work. It'll just detect everything on 80. No good. But if you really want to do it that way, you can. You'd actually just create a simple text file, name, and then .yaml. And you specify what's the name, what's the service name, what protocol, TCP, UDP, or both there in this case. What ports is it on, and then give it an app ID number. And you're done. But that's not at all interesting. Right. We want something a little more complicated. In fact, let's look at these Lewis scripts we're using to do a lot more things with application. Now, I want to show you the entire file. This is a Lewis script for doing this. This is the first part of it. And if it looks daunting, don't worry, because if you look at more than one application detector, you're going to see that most of these lines do not change between them. Right? There's very little here we actually have to pay attention to. If you're going to do an application detector, first place you'll probably open up another one, copy and paste it, and only change a couple fields to get going. Right? So a lot of this is just initiation. If we wanted to start our own application detector, there's only a couple things we'd have to change. I would want to make sure, I mean, give it a name here. And then you see in protocol, we want to make sure we're looking at the right protocol. Even that you don't usually change. I mean, TCP is most stuff, right? So that's sort of the header there. So most of the time we'll just blow past that. Not a lot to do there. And get into the functions where we're defining how we're going to identify this application. Again, a lot of mess on the screen. But again, a lot of this is just initiation of this function. If we look at what we're actually doing, it's really just this function. We're registering with this framework to create a new detector. This is where this is really going to happen. So what we're doing is using this add URL pattern function to specify a URL pattern. Right? So all I really have to do is specify circlecity.com. Right there, you see after that is just a /forward. If you wanted to include a subdirectory in the URL, we could do that. And then the last part of the HTTP is just, what are we going to see at the beginning of the URL. Right? So if I just want to track who's going to CircleCityCon, this is enough to get me going. This will now register. I can put this file in my application ID directory, restart snort, and now we'll have this detector running. But I also looked at a couple other things, like maybe we want to know exactly who's checking the schedule. Probably one of the more used pages, at least throughout today, certainly. So when we add another detector, and again, this really just comes down to this one function, where I'm going to say, in this case, we can also detect this. Again, CircleCity should say CircleCitycon. That's an error. That's not going to work. Then /talk/schedule. Again, we're sort of modifying that URL there. If we've got that in there, now we'll actually get specific stats coming back to, okay, who's going to that specific page. Right? App names have to be less than 16 characters. That's not in the documentation. But if you look through a couple application detectors, you'll see they're up, as short as name as we can get, not a lot of vowels, because that constraint is there. Let's see. And then I added one more. Maybe we want to track to see who's buying tickets to CircleCitycon. So in this case, it was actually often on a different site. If you go to the CircleCitycon website and click Get Tickets, it brings you here. brownpapertickets.com /event, and then the number there. So I add that to my, again, I'm just running this one Lewis script and putting these functions in there. Now I can do that. So there's the built-in directory, and now I see I've created a custom subdirectory, which Snort is actually going to check every time it starts to see what's in there. And I will move that into the Lewis subdirectory where it'll get read. Let me bring it up for you. at this angle, those colors are completely invisible. Is any of this? Okay. All right, so we've got our name here, protocol, like we saw before, and then we have our 3 detection functions I've loaded in there, right? One for circlecity.com, one for that but talks and schedule, and then another for buying tickets, right? So we'll start up Snort again. It was going so well. All right, there we go. All right, so we load the web page. I'm going to click over to tickets. Buy tickets here, and that will actually take me to this page. All right, shut that down. Now let me go take a look at my log files here. All right, so we saw Chrome hit DNS, and then it goes over HTTP. Again, Chrome's using Java there, and then Jabber. And then we see it hit the circlecitycon application ID, right? So over time, again, I've got my bytes and how much is transferred and received. So we're going to have application statistics for how many people are hitting it. If I create a snort rule to fire on this application, I'm also going to have the IPs involved and all the other information I can pull out of the packet that's getting flagged as well. So if we want to flag that information, we can. And then, of course, we see DNS resolve again when we switch sites, and then circlecitycon ticks was how I could shorten that down to get under 16 characters to have that fire as well, right? So now I've got data coming back on an app that was not included in the application detection package. And actually there's not a lot to go on, but I mean, I opened up a couple other application detectors and copied and pasted and changed a few things, and now I've got a circlecitycon application detector. Right. Now that's a pretty easy example. We're just going off URL. But there's a lot of other ways you can detect and everything else you can look for. Like, for example, it'll log if I'm going to Facebook from here. Can't see into that traffic at all. Right? So it's all default HTTPS. So my default, I'm not going to get to see a lot of what's going on when you're at Facebook, but I'll still know you're at Facebook because one of the application detector functions you can use is actually to track SSL cert pattern. Or if you want to look to see what the SSL CNAME is set to, you can do that. Right? So there are application detectors that will work for Facebook, for Gmail, for a lot of these web applications that, while yes, they're encrypted, we're able to pick out what they are just from the cert name before everything's encrypted. There's one specifically for our RTMP URLs. So if you want to focus specifically on streaming video, you can do that. So if you were worried about traffic loss for March Madness, we can add RTMP URL, ESPN.com. And that will actually match not blocking all of ESPN.com, but just the streaming video. And the last one there, MEMCMP, is actually just what bytes are you looking for. So you can actually do like maybe a traditional snort rule where you would say, okay, I'm looking for this series of bytes, this many bytes into the packet, or you specify where exactly you're looking for. So you can get very complicated as far as mapping out how an application works and what you're looking for, right? Now, most of those have been done, right? I mean, HTTP is in there, SSH is in there, HTTP and a lot of the things are in there. So at least people I've talked to before, like what kind of application, what kind of custom applications you need, most of it will come down to custom web apps. And I think for that, most custom web apps will be identified by either the SSL cert pattern or the URL pattern. And it's going to end up being like 99% of the stuff we do. Now, if you have other more complicated protocols, you can absolutely do that. There's a lot of examples in there, and then we've got full documentation on all these different detection functions coming out in next couple of months. But if you look around at my logs, let's go back to I can dig into this directory, and you'll see that I have all the application detectors included here. And again, they're all Lua scripts, so you can pop these open and check them out anytime you want. So if you want to see how we identify whether you're running an Xbox server, let's pop that open. And we dig into, we'll see, okay, it's looking for TCP traffic. Here's some patterns it's identifying, it's looking for. So these bytes, somewhere in the beginning, download pattern, so there's going to be a /content somewhere in there. And it's going to work over one of these ports. UDP 88, UDP 3074, TCP 3074. And then this being a more complicated application to detect, there's actually other functions defined in the script, so that not only can you say, I'm going to match these patterns, but once you've matched those, run the data through these validator scripts, right? Because maybe we know of a couple false positives, and we're going to check for those first before we sign off on it. So you embed a couple other validation scripts in here, and now you can get very, very complicated as far as what application you're looking for. Right? Not sure just how much time I have left. This isn't so new, but it's a little new. Well, I want to point out that a lot of people don't know you can actually do a lot with file inspection with Snort now as well. Again, it's not one of the things that are on by default, and I don't think a lot of people are playing with it, but there are file APIs and file inspect preprocessor that you can use as well. So if you actually dig through that, you can actually do file type identification. So there's files going across, you want to actually do that, so they actually goes by the file magic, right? We're not looking at, oh, it ends in .exe, it's looking into the file, checking certain bytes there to actually figure out what the file type is. You can also grab a file signature, which SHA-256 is encoded in there. I mean, it wouldn't be hard to change the source if you wanted MD5 instead, but it's doing SHA-256. So if you wanted to grab signatures of files as they go across your network, you can do that. And you can also capture files this way. So if you want to load up Snort to pull out files as they're being transferred across your network, you can do that as well. So it lets you do file control. So you can actually block files by type or by signature. So if you just want to flat out say, okay, no one should be able to transfer a .jar file across the network, then let's stop that from happening. Just block that when we see it. Or if you want to block by signature, you can actually give like a list of SHA-256s and say, okay, well, if you see those files, then block it. And of course, capture files. So you can actually set up to say, okay, well, just all the files you see, send it to this directory, or you can actually say send it to a remote host. If you have storage set up somewhere else and you want to capture files there, you can actually just give it IP and port in the snort.conf, and it will send the files there. And again, in that tools subdirectory I mentioned, there's like a Snort file server script that will show you, like, you just run this and it will take files being sent to it. It slows Snort down a lot. So the question kind of becomes, like, is Snort going to run into resource constraints? Doing file signatures and file captures takes a lot more memory than Snort usually takes. So if your system doesn't quite have the RAM or CPU for it, then yes, that's possible. Yeah, so there's the app ID as well. The app ID takes a bit of performance. I mean, 20%. The file stuff more, depending on how many files are really out there. How big they are is another big part of it. That can absolutely affect performance. But it's really going to come down to whether the process itself is getting into trouble as far as whether it's going to affect your network. We're going to pull files out: HTTP, SMTP, IMAP, POP3, FTP, and SMB. And again, the signatures we have right now are just SHA-2v6, but that wouldn't be hard to modify. Not today, no. All right. You just have to compile with this flag, enable file inspect, to get it in there. When you compile, then you'll be able to do it. You add, again, your config file to your snort.conf, and it just gives you a few options to play with. You can go with the defaults. You don't really have to specify much, but then you'll get the ability to say, okay, how far into a file should we go? How much memory you want to set aside for rebuilding files? How large a file we go, so you can get like a file capture max and say, like, any file bigger than this, don't bother doing it, right? Because if you have to rebuild this file as we see in network packets, so that's all kind of stored in memory as we're doing it. We can also do a file minimum. So maybe you just say, look, any file less than so many bytes probably isn't in any way interesting. Maybe you can ignore all that. And then we can add another preprocessor for file inspect. And we can actually say, okay, I want to track file type and signature, and then give it the directory where you want to store files. The 300 there is like how much space do I want to set aside for that. In this case, we just say, look, never use more than 300 megs for storing these files. If you get that, then let's start deleting older ones so we don't have to worry about it. I can set the queue size, how many files we'll be working on at any time, and if I give it the blacklist, block.txt or whatever file it is, it will read that file. If there's any SHA-2v6s in there, of course, it's not going to be able to block those files as we figure out the signature. There's a file that comes with Snort, filemagic.conf. If you include that, now we're going to have the ability, it'll read in all the different file types we have, so you can detect those. So for most file types out of the box, so to speak, out of the tarball, Snort will be able to just pick up most file types we've seen before. SHA-2v6, wherever you want to get SHA-2v6, if you want to pull it from VirusTotal, right, you can plop it in that text file, restart Snort, we'll be blocking it, or if you've got a file, right, we just run the command, generate a SHA-2v6, and add it to the file, and now we'll be blocking that file. I don't know what time we'll be able to capture, I mentioned that. Of course, we can get alerts based on that. If you want to alert anytime you see a certain particular file or file type, you'll get a file, okay, here's the URL this file is downloaded, here's the signature, there's a SHA-2v6 for it, and then what IPs we're transferring it when it picked it up. All right, so again, all this is built into Snort. You hit snort.org, you can download all the stuff I showed you today. There are some blog posts on the Snort blog, you'll see there on the same page, that can walk you through setting up like a lot of the OpenAppID stuff. And we're starting to get more and more custom detection out there as well. So we're really going to hope to see the community sort of take off with that. The idea being we can get application detection everywhere. It was this hot new security thing, like, hey, we're detecting applications, this is great, this is next generation. And at the end of the day, isn't that hard or interesting? So here it is, open source, go nuts, right? It's all community driven now, so completely free, as in speech, as in beer, and I'm part of the community. Okay. All right, so what time I have, I'll take questions about any of the stuff we've got. Yeah. Sorry, you're a little quiet. That would prevent it from running what? Oh, to get this up and running on? Yeah, if you hit snort.org and go to the documentation page, there are guides for getting it running on most Unix flavors. Not Linux, but mostly Unix. I'm told there's some people who kind of get it working on Windows. I don't know why. Yeah, that's all right. But yeah, there are definitely people running on BSD. I don't know if this version's been run on BSD yet. This is well, so it's in Snort 297 alpha is what's out right now. I don't think so. I mean, if anything that ran snort before and can also run Lua, I can't foresee a reason it wouldn't work. It means not as many people have tried yet, and maybe you find a bug. It is an alpha release, but I don't see any reason you couldn't compile it and get it up and running. Yeah, no problem. Yes. Mm. Would it be worthwhile? There's a lot written for it, right? So if you go through the application detectors, you'll see a lot written for it. So if I look at let's see what's available just for Facebook. Facebook apps, Facebook chat, commenting on Facebook, reading email, sending email, status updates, search, events, whether they're posting to Facebook, video chat, Facebook message, Facebook video. So if we were cracking SSL, you could get down to the point where you could say, okay, I don't care if you go out and read Facebook, but I'm going to stop you from chatting. I'm going to stop you from playing Farmville. Right? Now, is that useful? The question is ultimately, what's your company's security policy? And it's worth asking, because I was just talking about this earlier, but I've had a lot of customers say, I need Next Generation Firewall and I need application control because it's new and interesting. And I'd say about half the time we say, well, what's your security policy? What applications do you need to block? And they're like, we don't really block anything. So is it interesting? Is it useful? It entirely depends on your organization's security policy and what you're actually interested on getting information on or controlling, right? So if you want information on how much is time spent on Facebook email, or the ability to block mafia wars specifically, then there's value in getting into the SSL. If your whole thing is like, I kind of want to know what's going out there, I want to see if anybody's using BitTorrent or any other P2P stuff, then no, that probably wouldn't add a lot of extra stuff. But at the end of the day, it's going to come down to what's interesting to you, what can you do with the data, and would your policy even let you block it? Does that answer your question? Okay. Let's see. I'm hitting the end of my time. So I've got a few minutes to go around if you have any other questions. I've got some cards. If I do have to run out of here, contact information was on the slide. I leave some cards here if you want to get a hold of me. I'm sorry I have to run so quick. Any other questions, please feel free to let me know. If you have a chance to get this up and running, let me know. Any other questions, let me know. Have fun with it. Thank you.